W.E. Garwood. He's retired. The title of his talk is The Chemical Constituents in Petroleum, State of the Art, 1945.
I first want to thank Bert Davis for asking me to do this. Bert gave me a chance to reminisce some about the old days. This button's here somewhere.
Here.
As I said, I thank Bert Davis for asking me to do this. Gave me a chance to reminisce about the old days. Lots of memories, most of them pleasant. Let's see, I'll put this over here. I apologize for the fuzz in this. It's hard to Xerox a book and not have shadows come into it. What I did, I picked out one of my books I have from the old days. This publication by Dr. Sullivan, The Chemical Constituents of Petroleum, published 1945. It's a 425-page book. The Reinhold Publishing Company doesn't exist anymore, so it's a book that's history. You can't get it. The preface of the book, he states the ultimate goal of petroleum chemistry in its analytical aspects is to resolve petroleum into individual hydrocarbons and other constituents. Conspicuous progress along this line has been accomplished during the last 10 years, owing particularly to the efforts of the National Bureau of Standards. So, the National Bureau of Standards, I had my daughter check in Google. I don't do Google. It was the National Bureau of Standards was an act of Congress in March 3rd, 1901, and its name was changed in 1988 to the National Institute of Standards and Technology. So it is a prestigious part of the Chamber of Commerce, and back at that time, 10 years before 45 would be 35 to 45. So that was an era when petroleum was on a high learning curve. Prior to that time, of course, all they did was stick in the ground, get the oil, sell it, taste it to see whether it was sour or sweet. So this book I found was really a classic. And his next statement was, a large literature on the chemical composition of petroleum is used on the basis of its reliability. Many unreliable data have not been included to avoid unnecessary criticism by the author, and equally unnecessary increase in the size. So I'm going to discuss what I have to talk about will be from this book, and I wrote down the chapters. The 10 chapters in the book. I want you to look at the references. I added that in. Back at that time, when you wrote a book or wrote a paper, those of you who did that, if you change your references, all the work would be involved in changing the whole list and having to retype things. And so he did a tremendous amount of work on this. First chapter is on petroleum gases and natural gasoline, physical methods of determining hydrocarbon, chemical methods, hydrocarbons as straight-run distillates, hydrocarbons as synthetic distillates, petroleum racks, oxygen compounds, sulfur and nitrogen compounds, resins and phosphatic products, and classification of crude oils. Now, what I'm going to do is talk about some highlights in these various chapters. I'm not going to spend a lot of time on any one. I just want to give you a feel for the nature of the book. On the physical methods, distillation number one. Of course, that distillation is still a matter of getting new techniques in distillation than it was back then. So that was in 1945. That was being used a lot. Crystallization, of course, sorption, desorption, solvent treatment, critical solubility temperature, specific gravity refractive index, refractive intercept, and specific dispersion methods based on other physical properties, infrared, ultraviolet, mass spectrometry, and X-rays. Now, mass spec at that period of time was in its infancy. Publications in 1935 listed in the book. Now at Mobile, we got our first mass spec in June of 1947. Before that time, it's hard to imagine working in the petroleum labs and not having mass spec available. And of course, this is years before GC. And of course, X-rays. Chemical methods, I'm not going to go over all of these. Of course, determination of hydrogen-carbon ratio. Of course, that was, remembering qualitative organic, you had to determine hydrogen and carbon. So that was, of course, basic to the study of petroleum, ring analyses, dehydrogenation of cyclohexanes into aromatic hydrocarbons. That makes you think of reforming, which didn't exist at that time, of course. I wanted to mention also the bromine and iodine numbers. Of course, we all use that in our laboratory work. Hydrogenation of unsaturated and aromatic hydrocarbons. That was an analytical method, but of course hydrogen was not available at that time for reforming, if you can imagine that. Reaction of tertiary hydrocarbons, oxidation. I wanted to show some of the data they had that's in the book. Dry gases composition, the extensive use of distillation pod-millionate columns. The old pod columns, most of you probably never even heard of them. They were ceiling high, and we had 4 of them in one lab at that time, and syn crudes would be submitted to the analyst, and this was done under very specific conditions. And even the lighter boiling, you chilled it down as charged material. And that took 24 hours or more. They were running continuously. And that was the only way you had of knowing what the components were. As I said before, mass spec, when mass spec came, that was just like that. So that shows this was produced in the Hoover process. Now I'm sure look, some of you remember that too. That was the old fixed bed that Eugene Hoover brought to this country from France. And he was brought over by a mobile management and worked in our lab first. I never knew him personally. I heard him give a talk. He was a very colorful person. He was a captain in the French army. So, of course, at this time, the catalytic cracking, that was the only, in World War II, that supplied a lot of the naphtha and the gasoline for the machines in World War II. The beads were just being made, and catalytic cracking, moving beds were an object of much research. but with no publications. Of course, that wasn't Dr. Stockton's objective necessarily, but there were no publications on the products from catalytic cracking in the moving bed. Composition of natural gasoline. It's impressive to me that they could determine all these individual components. I'm not going to go over that in detail. Again, I won't go over this in detail, but you can see the aromatic portion of these Texas naphtha, all these individual aromatic compounds that they were able to determine. Aniline points. Critical temperature of the solubility of a substance in aniline, that is, the temperature of its complete solubility with aniline, lowest for aromatics and highest for paraffins, used very extensively because of its simplicity. Now that was a standard analytical technique in our labs. And what's amazing, all these different hydrocarbons, the aniline point is down to a tenth of a degree centigrade. And this was actually used to determine these compounds. It seems in this sophisticated day that something this simple would have so much utility back at that time. We used that a lot during my era. I retired in 1987. But I've been told that that was used up to 10 years ago in classification of crudes because it was so simple. This is straight run gasoline. And here again, I pointed out here that aniline point was used in the chemical composition of these straight run gasolines from various parts of the country, Canada. Alkylate gasoline. I found this very interesting. Of course, HF alkylation was being used in World War II for high-octane gasoline for the Air Force, and we were doing it in our labs. And he points out here that sulfuric acid, aluminum chloride, hydrogen fluoride, boron chloride used as a catalyst form very similar outlets from isobutane and certain olefins. And these are all listed here. If any of you have worked with HF, you know what miserable stuff it is. And back in those days, we were not very worried about safety that much. I remember getting some under my fingernail and it ate down halfway down the next morning. I observed that. We had a medical student one summer working with us, and he said he wanted to have our bodies when we died to see all the scar tissue in our lungs. Now HF is still used, of course, but it's a baddie. But because it's so efficient, oil companies are still able to use it despite its potential hazard if it breaks loose. Lubricating oils, again, I won't go into any detail here, but they were all able to characterize them in terms they use aniline point here for aromatic rings, naphthene rings, paraffin side chains. Synthetic lubricants. Sullivan, he was Standard Oil of Indiana, I think. This was published in the 1930s for his work with aluminum chloride, where he tried all manner of mainly olefins, various olefins. Most of them, of course, didn't show much utility. The one that the octene 1 was one of the better ones. Octene 1 here, VI of 108, 4 point minus 20. The track waxes gave the best materials, really. VIs over 100, 4 points below zero. But this never got commercialized. During the war, of course, synthetic lubricants were projects were working on that. I did myself some when I came back from service. But it never really got made the grade because like at that time, the exploration in the Middle East, there was lots of petroleum available. The waxes, again, separation, then no mention of various solvents or process. In 1945, that was an area of a lot of research also, and the solvent dewaxing, but it didn't get into the publications. I think companies didn't want to publish it too much at that particular time. Crude oils, he pointed out that they should be based on the chemical composition, but they of course were able to paraffinic all the way down to aromatic asphaltic, and they were classified, of course. And I mentioned, you've probably heard of sweet and sour crudes. That was the initial way of determining whether the crude had a lot of sulfur or not. If it was sweet, it was low in sulfur. If it was sour, it was high in sulfur. Late I didn't look after that. Sulfur and nitrogen compounds, that was very primitive knowledge at that time. Sulfur limited mostly to gasolines and naphthas. Nitrogens, there's practically nothing known of the chemical nature of non-basic nitrogen compounds, several nitrogen bases. Of course, that is still an object of some work. You will still read publications. And sulfur and nitrogen are still critical, as mentioned by Dr. Dolbear. That's still an ongoing area of interest. Now I have 10 more minutes. So I'd like to reminisce in my abstract. I mentioned I wanted to reminisce a little bit about Dr. Stockton. This is a book he wrote. He did that in 2 years' time when he was in he didn't have to act as a manager. And he did a tremendous job on it. And some of those publications were actually in Russian, where he had published that before he came to this country. He made the rounds of the labs frequently. I remember him coming to me and saying, "Hello, Bill, what's new?" And he was interested in every one of the researchers. He took a special interest in World War II returnees. He was a very patriotic person, having come from Russia. He appreciated American life. And I know, in my own case, I never took it. He wanted to give us a chance because he figures, I guess, that they owe that to us. And I think that was the nature in petroleum companies at that time, that were those who came back from overseas in World War II had good job opportunities. Of course, they had missed out on some years in their life, but that seemed to be something that was one of the plus sides for those who were in the war. And Dr. Stockton insisted on not giving up in catalysis till the variables of temperature, pressure, and contact time are all explored. If you said this didn't work, he would ask you questions. And so for me, that was a major influence in my career in my very early days, that when you did something, you did it right, and you didn't stop on saying this doesn't work till you did investigate these things. And in catalysis, that's the name of the game. I'm sure you can all speak for that same sort of thing. Who, in your early part of your career, who really got you started. I just want to talk about my own career experiences a little personal stuff. I was hired in 1942 with a PhD degree at the University of North Carolina. to do adjunct work, which was done in glass fast. I was in the Navy 44 to 46. When I came back, they were working on synthetic lubes, and I was involved in that for a year. And then those projects were all terminated. There was no more interest in that. And then I was transferred to some catalysis work in continuous pressure units for the rest of my career as a chemist. And chemists aren't supposed to know how to do this. They just work with glass fast. But at the time, I thought I made the mistake of showing that I could run units. And it's the best thing that could have happened to me, because what you can do with these, of course, with glass flask, you're limited in temperature and pressure. With a continuous pressure unit, a micro unit, which we developed, you can go up in temperature, you can go up in pressure, you can do so many things. And in contact time, you have all these variables to work with. And to me, that was working in catalysis it never got boring. You have these continuous units going overnight, weekends, and every day changing it. To me, it was a great career doing that, even though there were some downsides to it. And in my case, I only had an undergraduate degree, but I took graduate courses in the Temple Night School. I needed to have the knowledge to do this because I had to compete with PhDs all the time. And of course, back at that time, without a PhD, you could still do research. Of course, those days are long gone, and without a PhD, forget it. But so I was able to do the work, and that's what Mobile wanted, of course. And I stayed on the technical ladder. Management ladders are essential, and it takes good managers, but this is where the real fun is, in my opinion. Now, we have some time here, and I wanted to see if there's anybody here who worked in the lab in 1945. Is there anybody here that did? I don't see any hands. So I guess that no one can argue with me then. So I guess, can you still hear me? I guess there's time for questions, Mr. Chairman.
Are there any questions for?
Or comments. If somebody wants to just reminisce a little bit, please do. I had that in my abstract. Yes.
As long as we're on history, let me mention the contribution of API Project Research Project 6, which identified over a number of years, Fred Rossini, as mayor, identified over 300 individual compounds in petroleum. I was fortunate enough to work on it.
Yeah, do you know what time frame that was?
It started probably in the 30s or 40s and ended in the late 60s when Rossini got it.
The API Project 42 and high hydrocarbons, that was another one. Yeah, that API work was really petroleum, that's where it was.
Okay, any other questions, comments? Okay, well, thank you very much. Appreciate it.